Welcome back, grade 12s. We're getting into electric circuits now. This is a really important section, and I can almost put my head on the block that you're going to get something to do with electric circuits. Yes, it's possible you'll get either electrostatics or a capacitor question, but I think the chances are that you're definitely going to get an electric circuit question. Remember, this fits into the bigger picture of electromagnetism or electricity and magnetism, and so you will get questions on electrodynamics as well, but we need to pick up exactly what we're going through here. So we're starting with circuit problems, and one of the things that recent examiners have been doing investigation type questions. Here's an example of one that was in last year's final exam paper, where they did an investigation with Ohm's law. So let's read about it. It's our question 3. It says learners conducted an investigation to verify Ohm's law. So they weren't trying something new. They measured the current through a conductor for different potential differences across the ends. So the results obtained are shown in the graph. So they plotted for different potential differences, which they chose. They plotted the current, and so they've put the graph of current versus potential difference. Which one of the measured quantities is the dependent variable? Very important question. When you're doing an experiment, you need to identify which is your independent variable and which is your dependent. The one that you choose, the one that you control, is your independent variable. The one that you measure as a consequence is your dependent variable. In this case, they changed the potential differences, so that was the independent variable, and the one that is the dependent variable is the one on the vertical axis, which is the current. Now, next part of the question says, the graph deviates from Ohm's law at some point. Write down the coordinates of the plotted point on the graph beyond which Ohm's law is not obeyed. So if you take a look at the graph, you'll see that initially we've got a very definite straight line. Take a straight line over there, and you'll see that it continues in a straight line past that point. So if I just get it on top of my line there like that, you can see that there's a point of deviation. Deviation means where it's no longer going straight. We're wanting those coordinates. You can see the potential difference is a value, an independent value of 4, 0. So for potential differences greater than 4, 0, you're not going to be obeying Ohm's law. Notice that there's the deviation. You can see the deviation. It's bending like that. But what they wanted is the coordinates of the point that I've measured over there, or I've ringed over there. And if we just take another straight line and we take the point like that, you can see where it falls on the vertical axis. So we're wanting to know that it's from here up to there, which is on the 4, 0. So the coordinates of the point are 4, 0. 4, 0 is the horizontal value, or the independent variable. That's my independent value, which is for the potential difference measured in volts, and the current value is going to be, look at it, it's between 0,6 and 0,7, and it goes up in small blocks of, there are 5 small blocks, 1, 2, 3, 4, 5, so it goes up in values of 0,02, so that's going to be 0,04, so the Y value, the current value, is 0,64 amps. This was volts, that was amps, and I think we've got that sorted out. Make sure that when you've got a graph that you read it carefully. Determine the scale. Make sure that you can read it off and you've got it very accurately. And we can move on. The next thing it asks us is give a possible reason for the deviation from Ohm's law as shown on the graph. Assume that all the measurements are correct. Now we might think that the instruments had failed or whatever, but you must remember that Ohm's law describes a special relationship at constant temperature. So what we'd have to say, the deviation is probably because the temperature was not constant. The temperature was not constant. And that's the reason why most things are non-ohmic, why they deviate, like light bulbs, because as they heat up, the resistance changes, and so they no longer obey Ohm's law. Let's move on. Use the graph to calculate the resistance of the resistor. So what we're going to do is we're just going to look at the region between that it is ohmic. In this region, where the gradient here is constant. We'll notice it's a straight line, and the gradient is constant. So what is the gradient of this graph? I want you to see, we say M is the gradient, and it's the change in current over the change in potential difference. But because it's a straight line, it's actually the ratio of current to potential difference. What you notice here is this isn't giving us the normal Ohm's law. Remember, R is usually and is expressed as V over I. So the gradient here is not going to give us the resistance, but it gives us a very interesting way to find the resistance. So what we're going to do is we're going to find the gradient, or just find the ratio of 2 points. That will do it for us. And once we've got that, because the gradient is constant, it will always be that same ratio, we can then just invert it and work it out. Now, as I said, there are many possibilities. We could choose a point such as this one over here, or we could say, let's do final minus initial. That would also work, but I like to just choose that point there. So the potential difference of 2, and let's have a look at what the current is. And I think you can see that it's going to be 0.32. So if we take the relationship that we've got there, we've got a current value and we've got a potential difference value. So if I'm wanting to find resistance, can't I just read them off and substitute them into the formula? Well, why not? I can say that at a particular point, I'm going to use the graph, and I'm going to say, I know that for V equal to 2,0 volts, that the current from the graph is equal to 0, I've made a mistake there. It's 0.32 amps. Now, I could work out the gradient, but here's a shorter way of doing it. I want R. I want to work out the resistance. I'm going to say it's V over I, substitute my value in 2,0 divided by 0.32. Let's do that on the calculator, and we'll say 2 divided by 0.32. It's equal to a fraction 25 over 4. Change the fraction to 6.25, and that looks like a reasonable value for a resistor, 6.25 ohms. Now, of course, you could go a different way. There's nothing wrong with doing a different way. You could calculate the gradient of this graph, say what the gradient is, and then invert it. But please don't make a mistake. Don't forget that what resistance is the ratio between potential difference divided by current. And we need to make sure of that. Okay, now let's move on to a classic example of another circuit problem. Have a look at this one. Question number 4 says the circuit on the following page or down below shows a battery. Now, battery is made up of more than one cell, consisting of 4 1,5 volt cells. They're connected in series, also very important information. An ammeter usually has negligible resistance or very low resistance. It's connected in series to the battery. That's important. Take a look at it over there. We know that that's reading the maximum current. Okay? It's reading the total current when the switch is closed. Important at the moment in this diagram, the switch is open, but when it's closed, that will read the current passing through the battery and through the main part of the circuit. The connectors have negligible resistance. The voltmeters have very high resistance. Voltmeter V1 has a reading of 5,5 volts, 5,5 volts, when the switch is closed. So this is reading the potential difference of the external circuit. When the switch is closed, when we close the switch, it reads 5,5, and we're happy with that. So now it says to us, calculate the value of the internal resistance of a single cell. Guys, we need to have our wits about us here. We need to make sure that we've got all the information sorted out. We need to know the difference between potential difference in an external circuit and that thing called EMF. As soon as they mention internal resistance, you know you've got to deal with EMF. So let's start and see how we can calculate EMF. Well, the first thing that we're told in the information that gives the clue to us is that we've got 4 cells and they're each 1,5 volts. So I reckon that if I want to get the EMF of this battery, I'm going to have to say it's 4 times 1,5, which is 6 volts. Notice as well that we already know that the potential difference when the switch is closed across the battery, this would be the reading on the V1 on open circuit. If the switch was open, that's what V1 would read. It would read the EMF. When the switch is closed, it's reading 5,5 volts. So notice there's a change in the potential difference. That change is sometimes known as lost volts. It's also recognized as the potential difference of work done inside the battery, and we can see that it's the EMF minus the V external, and if we take a look at that, we can say it's 6 volts minus 5,5 volts, which is going to give you 0,5 volts. Now, what's actually happening to inside the battery? Well, these lost volts. Well, it takes the charges some work to get through the internal resistance. So let's work out. Initially, we need to recognize that V lost is equal to the total current times the total internal resistance. But I've got a problem. I don't know what the total current is just yet, because I haven't been told, oh, there it is. I've been told that the ammeter reads 0,5. So the maximum current is 0,5 amps. Always good to go back to the question and that we can use it there. So if we substitute in now, we're going to recognize that lost volts, we can use this equation and we can say the lost volts was 0,5 is equal to the current 0,5 times little r. So of the battery, this was the battery, is going to be 0,5 divided by 0,5, which is going to be 1. So guys, what is the battery's internal resistance? 1 ohm. Don't forget the unit. But we weren't asked to find the internal resistance of the battery. Remember, the battery was consisting of 4 cells. So we want to know the internal resistance of 1 cell. Then it makes sense that it's going to be the resistance of the battery divided by 4, which is going to be 0,25 ohms. So each of the cells contributes 0,25 ohms to the total. Well, guys, I hope you don't get stuck on electric circuits. This section is there for you to do really well. It's a wonderful section. You just need to do a bit of revision from your grade 11 work and from previous years. Make sure that you're very clued up about circuits, about electrostatics. I wish you everything of the best. Bye for now.